Okay, good morning. I think we can start a session. It's 9 a.m. If you can hear me, you can use the chat box and we will just start right away. I think you can hear. Yes, thank you. Thank you, Tony. You can, of course, you can try to mute your microphones, then we don't have this feedback. But chat box, of course, we can use it. Okay, that means this is the second or theoretically the third part of the final exam review. And just one more time, I will remind you the test will be open Friday and will be closed Thursday next week, August 8th. And August 2nd is the opening day. That means we still have a few days. And I hope everyone has an appointment at Examity because that's important because it's the latest, the last minute booking, it's not recommended because it's too crowded, it's the final exam time, everybody wants to pick the convenient time. But you remember, I recommend this at the beginning of the semester and most of you did your appointments, which is great. Okay, that's what we have. Today I will talk about chapter 11 and then chapter 10. We know the order. And also I saw just yesterday 2 questions on the discussion board. I will also solve these problems. We can even start with these problems maybe because I didn't type the solution and I said I will solve today. Okay, that means let's start. If you have any question, as always, use the chat box. You can interrupt me anytime and I will be more than happy to answer your question. Okay, let me move to my other screen. I'm still there. That's what we will have. Oh, I can maybe move this way. Okay, that's we know this information. I did post this on the main, on the front page on Canvas. That means you can expect 25 problems. Approximately 50% is all the old stuff from exam 1 and exam 2, and 50% of the test will be the new concepts, new material after exam 2. And as always, no calculators, notes, textbooks. Taking your test at Examity, always make sure that you pick the nice, tightest room. Pick the desk that is that has no notes, no books. Then the proctor will not bother you. Yeah, just don't give him or her an option to ask you additional questions. Okay, then they will not bother you and you will take your test without the stress. Okay, and I think I said 120, but I think I'm giving you one extra 10 minutes since everything is online for the settings for to have some extra time. That we do have plenty of time. And another thing that I will recommend always, please go and please check your exam 1 and exam 2 material. Okay, because we may repeat some questions. Yeah, that's check. And of course, all of the weekly quizzes are important and this session. Okay, don't miss any question. Okay, let's see. That's what I will do. Chapter 11 and 10, but this is actually, I have the first slide with the sequences, which I believe was covered yesterday, but we can still go really quickly. You can probably give me the answer. And I will be so happy if you will know the answer almost right away, yeah, for these sequences. But I will just go really quickly through all of my slides just to reach the empty slide and I will solve the question from the discussion. That means the first question, almost the last question on the discussion board was, I believe, is from the textbook. But the question was, we did have 2 polar curves, r equals to 3 cosine theta and r equals to 3 sine theta. And we have to find the area of the region which is inside both of the curves. Okay, inside both. Okay, what I will do, I will draw them. And let's see what was the confusion. Oh, no, not really. I shouldn't do like that. This is 0, of course. That's 90, because it's not really the Cartesian plane. That's 180, 270, and 360 full revolution. Okay, and we know that just cosine and just sine theta, that's the circles. Cosine will take place in the first and the fourth quadrant. I will draw a circle, and this is of course 3. And sine is positive in the first and the second quadrant, then the circle is placed. I just want them because they are the same size. I have this weird lines, okay, and this is 3. Okay, and we can see inside both, I believe, is just that loop. Yeah, we have to find the area of this loop. Point of the intersections are important, which I can even draw this line. That will be the angle. You can probably guess, yeah, what is that angle, but let's solve it. Yeah, points of intersection. 3 cosine theta must be the same like 3 sine theta. How can we solve it? We can definitely divide by 3. And maybe you know for what angle cosine and sine are the same. Yeah, has the same value. Of course, it's pi. Thank you, Ramiro. It's pi over 4. If we really like to see the solution, I mean, I can divide both sides by cosine theta. Cosine by cosine is 1. Sine by cosine is tangent. That's maybe this way. Tangent for what angle is 1? It's of course the same, pi over 4. But you may know right away. Okay, that means this is 45. Pi over 4. Okay, oh, I don't know why it's changing. And now we have to think, of course, that line pi over 4, 45, is dividing the region by exactly like in 2 equals halves. Yeah, I mean, the halves are always equal, but yeah, to the same region, because everything is symmetric, even if we can't really see. Okay, that's we have to set up an integral. Of course, we remember that the area of the region bounded by the polar curve is defined as the integral 1/2 r squared d theta from A to B. If we have 2 of them, we have to like subtract. Okay, but what I will try possibly maybe to define the area just of this part. Okay, we can see just of this part. And if I will draw, we can see this part is including only one of the curve. I can possibly draw, let's draw that sine circle and the line 45. And this is that part. I mean, I would say it's an integral from 0 to pi over 4, okay? And it's only bounded by sine 1/2, and then my r, my curve is just 3 sine theta d theta. And since I want another half, I can use different color, yeah, the green one. I don't have to set up another integral. I can just multiply by 2. Okay, that means this is, that's in the green box is the final answer. And we don't really have to. I mean, we can simplify 2 times 1/2, maybe 9 sine square theta, but that's at the moment everything. And it's from 0 to 45. We can see that's, yeah, that's the region. Because I think the question was why we just using one curve. We don't have to subtract in this case. Because subtracting will not really give, probably when I will try to subtract like the top minus the bottom, which actually I can't even say this way because I have to say longer radius and the shorter, I will accidentally involve that part and this part. And we don't wanna play with this. Okay, that means this was one question. And another question was, I believe, from section 10.3, number 17. I think we did have a polar curve, just r equals to 5 cosine theta, okay, which actually we know the shape. But they ask to convert to get the Cartesian equation. Okay? And always when you will have the question to convert, do you remember my session, what I said? We have 4 equations. Whatever the question asks, but if it's like the conversion, you have to leave in your notes. Okay? X squared plus y squared is r squared. X is r cosine theta. Y is r sine theta. And then tan theta, it's y over x. Remember, put them down, just write them down. It's less than like 10 seconds. And then looking at them, we can try to eliminate r and theta and have x and y. That means what we will do. I will multiply both sides by r. This will be r squared, and this will be 5r cosine theta, right? And now let's see, r squared is just x squared plus y squared. And r times cosine, we can see r times cosine is just x. How easy it was. But I can tell you, without looking at these equations, probably I have to think longer. Yeah, it's so easy to put them down. Okay, this looks like a circle, but let's complete the square. I will subtract 5x. Okay, and then x squared minus 5x, and then I have to add the third number. I have to add the third number to complete the square. And the third number is the coefficient of x, which is 5, divided by 2 and square, which will be 25 over 4, and then adding the same number on the other side. Okay, and then we have x minus 5 over 2 plus y squared, and it's 25 over 4. This means that the circle is center in 5 halves and 0, and the radius is also 5 halves. But we know right away that circle, yeah, looking at the polar curve, that circle is just in the first and the fourth quadrant and diameter 5. And of course, this will be half of 5. Okay, but we can see that's the way. And probably, I like this. Maybe we don't have to really complete the square. Okay, but because the blue box, it's just x and y. It's definitely a Cartesian equation. The rest of the steps is just a little bit of algebra. But just overall, converting, yeah, remember to put them down. Okay, that's the questions from the discussion board. And now I will come back to my questions, and let's just solve, because I don't want to talk about like theoretical part, some proving, of course, no. We will just solve the most important questions that covers the most important concept, okay? Okay, that means, as I said, that was covered yesterday, but since I will talk about chapter 11, I also include section 11.1. Okay, all of them are the sequences, and we have to determine whether they are divergent or convergent. If they are convergent, we have to find a limit. Yeah? Okay, that means who can tell me what this sequence is convergent to, or maybe divergent? 1 plus 1 over n to the power of 7n. And of course, everything is as n goes to infinity. Yeah, because I will not rewrite. Yes, really good. We recognize the formula. 1 and 7, I'm not messed up, is e to the power of 7. Really good. Converges to e to the power of 7. Okay, what about the second one? Negative 1 to the n, and it's 4 to the power of 2n plus 1, and over 9 to the power of n minus 1. Okay? So we do have the alternating part. Then we have to check, because we can take the absolute value, which means the -1 to the n will be gone, and we have to check if this part goes to 0. Because if this part goes to 0, then it's 0. If this main part goes to different number, finite number, then we have the alternation. Like, let's say this goes, I don't know, to 5. Of course, it's wrong. Then we will have +5, -5, +5, -5, which is divergent. But if this part is approaching 0 at infinity, then we find, then everything is 0. And we can see, I can possibly write as a limit, okay, actually the absolute value. Okay, and now that's what I was going. This is 9 to the n and 9 to the -1. That's okay. That's just the coefficient. And on the top, I have 4 to the power of 2n. 4 to the power of 2 is 16. And then 4 to the power of 1. That's what we can see. We have 16 to the n versus 9 to the n. Okay? Denominator grows slower, or I can say the top numerator grows faster. Then this is actually infinity. This part goes to the infinity. Yeah, because it's 16 over n versus 9 over n. And up, so I can rewrite this. That means we have 16 and 9 to the n. This is just 4, and this is 9 to the -1. And we can say this is infinity, which means getting back to the original one, the same thing. Infinity is telling me that I have negative, positive, negative, positive. The whole sequence is divergent. Okay. Okay. This one, natural log 2n plus 1 minus natural log of n. We know that when we're dividing logarithms, we can, when we're subtracting, we can divide the numbers. And that means this limit, do you know the limit? Natural log 2n plus 1, yes, correct, ln of 2, and this. And the inside limit is 2, outside value function was ln of 2, converges to ln of 2. Really good. This one, cosine of n squared over n squared. Of course, cosine of, it's 0, because cosine of any angle, it's 1. N squared, of course, is like a big number. That's not really formal. 1 over big number is 0. Okay, we can think this way. Or we can think about the squeeze theorem. And the last one, we have e to the negative n, and we have e to the n. That means e to the negative n is not the leading function. Okay? I can actually even cross it. We're just looking at the leading functions, e to the n, e to the n. It's the same functions. Then what is the answer? If we have identical functions, the ratio of the leading coefficients works, of course. 2 over 4, which of course is 1/2. Yeah, okay, thank you for helping me. As we can see, relatively not complicated function and not time consuming. Okay, then let's start 11.2. We actually learned the geometric series and the telescoping in this, okay? And of course was the introduction to the series. Let's look at this one. Determine whether the series, and we do have something, is convergent or divergent. If converges, we have to find the sum. And we can see we have addition, which we will split for 2 series, but all of the n's are placed in the exponent. This means that we have a geometric series, but we have to split n from n to 1, and I have -1 to the n plus 1 over 3 to the n, and plus, of course, from 1 to infinity, 2 to the n minus 1 over 3 to the n. Okay, both of them are the geometric. And how can we check the common ratio? The common ratio is the quantity taken to the power of n. That means I see -1 to the n and I see 3 to the n. -1/3. -1/3 is it's less than 1 and greater than -1, because that's the range, that's the condition for the geometric series to be convergent. That we find to use the sum. And the sum, the formula, it's a over 1 minus r. Yeah, that means that's important part. And let's compute. A is the first term. And the first term will be, if I will take the formula, -1 to the n plus 1 over 3 to the n, and substitute 1. -1 to the power of 2, 3 to the 1, which is actually 1/3. Okay, 1/3, and then I can use my sum. 1/3, 1 minus -1/3. Let's compute the sum. Oh, yes, R cheat, it's helping me, 3 over 4, let's see. 1/3, and this will be addition, 4 over 3rd, and then I think we can multiply by 3, then we're losing this. I think I've got 1/4, or maybe you telling me the entire. No, okay, I've got 1/4 for this one. Am I right? 4 over 3, and then we will flip the numbers, will be 1/4. Okay, now let's work on the other part. We will, of course, we will add this. Okay, now let's see. Common ratio. 2 is taken to the power of n, and 3 is taken to the power of n. The same thing. This quantity is less than 1 and greater than -1. We may use the formula, because remember, this formula we can only use if the common ratio is from that interval. Okay, let's compute the first term. The first term will be 2, 1 minus 1, 3 to the power of 1. 2 to the power of 0 is 1, 3 to the power of 1 is 1. 3 to the power of 1 is 3. Actually, 1/3, the same thing. Let's compute. 1/3, 1 minus 2/3. 1/3, 1 minus 2/3 is 1/3. Oh, 1/3 over 1/3 is simply 1. 1 plus 1/4 is 5 over 4. Remember to add at the end, because the addition was, or subtract, depends what is in the question. Okay, that means that's the geometric. Okay, the geometric, I can, oh no, geometric series. My writing is not good. Okay, one of your questions done. Now we will, yes, now we will grab everything what we know about the series, all of the tests, everything, and try to determine what test to use and determine the convergence and divergence. Let's see. I have 2 different series, and we have to check which one is convergent, which one is divergent. Okay, this one is -1 to the n, it's alternating, and then n squared plus 2n plus 1 to the power of 2n, and quantity n cubed plus 1 taken to the power of n. That's, what do you think, the first one? What test will be the easiest one? The root test, of course, because that's what I was trying to make an accent even stronger than I have. n and n. The entire quantity is taken to the power of n. Yeah? That means we can definitely, for A, we can try to use the root test. I will change the color. We have to find a limit of the nth root of absolute value. Absolute value will eliminate my -1 to the n. I don't have to be worried about this. Now let's see the nth root, and we have n squared plus 2n plus 1 to the power of, now let me write just 2, and then n cubed plus 1, and everything it's taken to the power of n. Because I took that n and this n and I put as a common exponent. Okay, and now algebraically nth root and the power of n is gone. And what we have? We have just a limit at infinity of n squared, n squared. This will be n to the power of 4, and this will be n cubed. Yeah, we're just looking at the leading families, and I thought the other way. If the top is winning, of course, we can even simplify and we will end up with n. N goes to the infinity. Oh, okay, I don't even have to say this. It's divergent. Thank you. Yeah, thank you for telling me this. Maybe it's infinity, of course, not 0. If the denominator is winning, like 1 over big number, it's always 0. Oh, okay. Okay, that means it's divergent, divergent. Oh, actually, they saying why I'm even, that means it's divergent, okay. We can even add condition, yeah, conditionally, oh, absolutely. Okay, that means this is divergent by the root test. Good. Let me, okay, now B. Now, can I ask you, what test shall we use if we see lots of factorials? The ratio test. And shall I try? I don't know if I can try to use the ratio test. Ratio test is good when you see lots of different formulas, and also when you see factorials only. That means we will try to compute a limit, okay, at infinity of the ratio a sub n plus 1 over a sub n absolute value. And again, absolute value will remove my -1 to the n part. And let's create that limit. Limit at infinity. This will be n plus 1 factorial. Oh, and it's squared. Okay, n plus 1 factorial. 2n factorial. 2, because I have to do 2 and I have to add 1, which means that 2 I will distribute 2n plus 2. Okay, I will write 2n plus 2. 2n plus 2, still factorial. And now, dividing by a sub n, I will multiply by reciprocal. N factorial, because it's squared. Okay. And we can definitely simplify. Maybe I can use that line. Okay, I will say limit as n goes to the infinity. And n plus 1 factorial, I can rewrite as a n factorial times n plus 1. And another n plus 1, I can rewrite as a n factorial times n plus 1. And I can put 2n factorial. 2n plus 2, I can rewrite as a 2n factorial, and then 2n plus 1, 2n plus 2. And we have to fill it up to that number. And then I had this denominator, n factorial, n factorial. Why this is switching? Okay. And this and this, this and this is gone. This factorial and this factorial is gone. That means what stays? N plus 1 and n plus 1. Now you have to watch me, which is n squared and the rest of the terms, because it's n plus 1 and plus 1. And in the denominator, I have 2n plus 1 and 2n plus 2. When we will distribute, we will have 4n squared and the rest of the terms. Okay, that means we have actually the same degree now, n squared over 4n squared. The limit is 1/4. That means this one is definitely less than 1, and this one is absolutely convergent. Okay, by the ratio test. Okay, A is divergent, B is absolutely convergent. Okay? Both of them are really nice series. Okay. Let's move on. Now we have the list of 3 of them, and the same thing. We can do maybe a little bit like faster, but we have to determine whether they are absolutely convergent, conditionally convergent, or divergent. Okay, do you possibly know the first one? -1 to the n over 1 plus square root of n. What do you think? Because if you know right away, then you almost ready. Yeah, this one is nice, typical example. Actually, both of them, and even the last one, they are quite. Yeah, just by looking, we should know. Okay, but let's investigate. Having -1 to the n, you probably know that we can use alternating series test. That means at the moment, I'm not really testing the absolute value. No, I'm just testing the original one. That means the original one is alternating. I can use AST because I have -1 to the n, I have the alternating part. And for AST, I need my B sub n formula, which is just the main formula, 1 over 1 plus square root of n. Okay, and now we have to test if B sub n is positive, and I believe it is positive, if the limit of B sub n at infinity is 0, and we can see 1 over infinity is definitely 0, and we have to check if B sub n is decreasing. Okay, decreasing, and I think it is because we just making bigger denominator. When the denominator is bigger, the whole fraction is getting smaller and smaller, is decreasing. Okay, check, check, check. I can say this is convergent by AST. Great. Okay, that means it's convergent. I still don't know if it's absolutely convergent. Now, taking the absolute value, taking the absolute value, I will have only 1 because the -1 to the n will be gone. I can rewrite 1 over 1 plus root n. And what do you think? Taking absolute value, I can't use the AST anymore, okay, because I don't have alternation. And what do you think? 1 over square root of n. We can use comparison, or we can use direct comparison probably, or maybe limit comparison, depends what you, both of them could work sometimes, or maybe the direct is not working. Direct is not working because I will compare with 1 over root n, and my denominator will be, the whole fraction is smaller. Okay, direct is not working. Okay, the limit. But we can see right away n to the power of 1/2. Yeah, by the p-series test, this will be divergent. That means using the limit comparison, we're really getting divergence. Okay, because how I am like assuming right away, because I have n to the power of 1/2. That means it must be, if I will have just, let me write, just this one, yeah. Like without that 1 over root n, which is 1 over n to the power of 1/2, I will know right away, this 1/2 is less than 1, it is divergent. And logically thinking, that +1 is not really making an effect. Of course, to prove it nicely, you can use limit comparison, but we can see it's gonna definitely stay divergent. It's not a big like thing to add 1. Okay, that means it's divergent, which means it's not absolutely convergent, but it was as the original one, then we call conditionally convergent. Yeah, that means conditionally convergent, you should always get convergent as the original formula and divergent as the absolute value. Okay, then we can call conditionally convergent. Okay, what about B, the second one? -1 to the n, and n over n plus 1. Oh. Again, we can say, yeah, test for divergence, or even the AST. But however, I can't use really AST, because AST, alternating series test, is only good when we have convergence. When I will say check, check, and check, I have to satisfy all of this condition. AST is not proving divergence. And we can see right away, this is my B sub n formula. The limit at infinity is not 0, because n over n plus 1, the limit is 1. That's the reason that I can say divergent by the test for divergence, because the limit is different than 0. The limit, actually, this limit is just 1, but having alternation will be like +1, -1. The limit doesn't exist, simply. Okay, that means not, yeah? And we can say test for divergence. We can't really conclude divergence by AST. Okay, that's done. And C, I can definitely give you a small hint. Please remember, cosine n pi. Cosine n pi behaves exactly the same like -1 to the n. Okay, that's so important to know. I know that that was covered before, but cosine n pi is -1 to the n. Good formula to remember. Okay, that means I can rewrite, this is equivalent formula, yeah, because then we don't have this trigonometric look. We have just -1 to the n and n times root n. So what I have, I still have -1 to the n, which is alternating one, and I can combine this, n to the power of 1, n to the power of half, I can add, and I will have 3/2. Okay, and I can probably follow the same process like that we did for part A, or I can take a risk, kind of educated risk, and check absolute value right away. Because taking the absolute value, we actually changing my formula, we changing for 1 over n to the power of 3/2. And it's a beautiful p-series test. P is greater than 1, it is convergent, which means absolute value is convergent. It's absolutely convergent. Because if it is absolutely convergent, then we're done. Even getting back to A, if I will check absolute convergence and if we will get convergence, then we're done. But since we will get divergence, I still have to come back and do my alternating series test. Okay, as we can see, we have conditionally convergent, we have divergence, and we have AC, absolute convergence. Really nice selection. Okay, oh, that's me now. In order to, let me just stay for a while. In order to practice this, you can definitely check section 11.2, 3, 4. Okay, and probably 5. Yeah? And you remember in module, like, for these sections, I gave you like a summary. Section 11.7, I believe, was like a summary of all of the tests. You can check at the test and you can practice, but and you can look at the weekly quizzes and especially the sample tests. Okay, sample test, practice test, and the test from the last summer will give you like good like selection of the series to practice. Okay. But now what I will do, I will jump to the next section, which is 11.8, 9, 10, 11. Okay, that's we were talking about the power series. Okay, power series, and then we did have a few formulas. This is probably from my last slide, I can't remove. And we talk about the Taylor and Maclaurin. That means all of them, yeah, that I listed are the Maclaurin series, which is they are centered at 0. And we remember we did like, yeah, we did like derive the formulas. That means please, I mean, it's worth to like memorize them. Okay, we have to know that 1 over 1 minus x is just x to the power of n, and then e to the x is just x to the n over n factorial, sine, cosine, and inverse tangent of x. For all of these trigonometric, we have negative 1 to the n as a part of the formula. That means this is they are alternating. And then it's x to the power of 2n plus 1 and 2n plus 1 factorial. Inverse tangent is almost the same, but without factorial in the denominator. And cosine is even numbers, 2n, 2n. Okay? And of course, we do have they work. They are good for all of the numbers. The radius of convergence is infinity. But the first one and the last one, no. I don't want my pen to act funny. The last one and the first one is based on the geometric power series property. That means we have radius 1 only. Okay, that means remember that we have to know them. And now let's see what kind of question we can ask. Of course, we can ask for the radius of convergence, and we can ask for the interval of convergence. That means let's maybe try to do like one question each. And then let's see how we can use the other formulas. Okay, find the radius of convergence, R. And it's the infinite series from 1 to infinity, 5 to the n, n factorial, x plus 2 to the n, 3n factorial. Quite long, but we remember we will use, since it's lots of formulas, different form, we will use ratio test. Okay, a ratio test. Okay, let's try to build the ratio of this. Okay, limit as n goes to the infinity, and then 5 to the power of n plus 1, you probably practice a lot. That means I can write like that. 5 to the power of n, 5 to the power of 1. And then n plus 1 factorial. No. And then x plus 2 to the power of n, and x plus 2 to the power of 1. And then 3, and again, I will add 1 to the n, which means I have to distribute that 3. 3n plus 3 factorial. And then I have to multiply by the reciprocal. This will be 3n factorial. This will be 5 to the n factorial, x plus 2 to the n. And for this one, we have to keep absolute value, especially for the x plus 2. Okay, because x plus 2 could be negative, we still want everything positive. Okay, let's see what we have. We can definitely simplify a few things. That's the reason that we like ratio test, because it's nice to simplify. Okay, n plus 1 factorial, we know that is n factorial, n plus 1. Then I can cancel this. And let's work on the other parts. That means what stays on the top? 5. Okay, 5, and then n plus 1, the blue one, because that's what was my, and then x plus 2. Okay, and 3n factorial. I still have to get rid of this. Now, 3n plus 3 factorial, I can rewrite as a 3n factorial, and then 3n plus 1, 3n plus 2, up to 3n plus 3. Okay, and nothing else. Great. I can simplify my factorials because I have to do it. And now we remember the last step for the power series and the ratio test is to kind of like split the n's and x's. That means I have 5 times n plus 1, and then I will repeat this. 3n plus 1, 3n plus 2, 3n plus 3, and I don't have to keep absolute value for this, but I have to keep absolute value for x plus 2, as I said. Okay, who can tell me what is this limit? 0 or infinity? I think I know this in this case. It is 0, because now we have n versus 3n, 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 which will be n cubed. If the denominator is winning, we always have 0. Okay, and 0 times n x plus 2 will just give me 0. And 0 means, by the ratio test, okay, 0 means that is less than 1, which whatever power series we were testing, it's convergent always. Yeah, we can say always, which means for all of the numbers. That means having 0 in this type of question, what is the answer? What option you will choose? What is the radius of convergence? It's C is infinity. Thank you. As we can see, it's kind of like, because that's what sometimes we confused. Yeah? If you're getting 0 by the ratio test, do not pick the radius 0. It's actually kind of opposite. If you're getting infinity, then the radius is 0. It's kind of opposite. You may remember this way. Okay? But 0 means that it's convergent always means radius is infinity. Good? Really good and really good example. Okay, now I believe I have an interval, yeah, because that's a typical questions. Find an interval of convergence of the power series. And the same, good selection of different mathematical expression, 2 to the n, x plus 2 to the n, n. Yeah. We will also use the ratio test. So let's see. Ratio test. Limit as n goes to the infinity, a sub n plus 1 over a sub n. Absolute value definitely will let me to ignore this, but I still have to focus on the other. X plus 2 to the power of n and x plus 2 to the power of 1. N plus 1 and 2 to the power of n, 2 to the power of 1, and multiply by the reciprocals. Absolute value. I can simplify a little bit, this and this, this and this. And what stays? Oh, we have no factorials, okay. Limit as n actually goes to the infinity, and I have n on the top, and I have 2n plus 1, and then x plus 2. Okay, that's what is this limit, because we always have to separate, because limit it's related to n. That means only looking at the n. This limit is actually n over 2n, the ratio of the leading coefficient, 1/2. 1/2 times x plus 2. Okay, that means in this case, I didn't like get rid of x. My final answer is in terms of x. And we know convergence. We know that by the ratio test, the final answer by the ratio test must be less than 1 for convergence. Okay? We have to just solve this nice inequality. I will multiply both sides by 2, which I will have 2 on this side and 1/2 will be gone. And then I will eliminate absolute value, because in order for the absolute value to be less than 1, the quantity inside must be less than 2, between -2 and +2. And now let's subtract 2 from both sides. And this is almost my interval. Okay, my interval looks like from -4 to 0. Okay, -4 to 0. But we know that we have to test the endpoints. Oh, why it's not staying? Okay, -4, from -4 to 0. But do we know that if -4 will give me the convergence, or 0? And when I use these values and substitute here, because -4 plus 2 is -2. -2, absolute value of -2 is +2. +2 times half, it's 1. And when we getting 1, we know that the ratio test is inconclusive. The same when I substitute 0. That means I can't really use the ratio test anymore to test the endpoints, but I will just test them. I will just substitute to the main formula. That means let's substitute maybe 0 first, okay? Because if we will get 0, we can see 0 is included, it's not included, and it's included. We will see which one is good. Okay, what I need, I will substitute instead of x 0. And what I have? I will have -1 to the n plus 1 and x plus 2 to the power of n and 2 to the n. But x is 0, that means I only have 2 to the n. Okay, because 0 plus 2 is 2. 2 to the n will cancel out, and we have 1 over n, but alternating. Do you remember harmonic alternating harmonic series is actually convergent? Yeah? By AST, of course, because 1 over n will be positive, limit 0, and will be decreasing. That means actually this is convergent. Oh, that means I can include 0. Which means this is not an option. I still have to check if I'm including -4. Let's check. X equals to -4. Yeah, we have to be careful. -1 to the n plus 1 and 2 to the n. And now substituting -4 instead of x, let's see what we got. We will get -4 plus 2 is -2. Okay, that means -2 to the n. My writing. Okay, -1. No, and then -2. -2 to the n means that we have -1 to the n and we have 2 to the n. Yeah, that's -2 to the n. I just split because I would like to get rid of this. And what we have now? We have -1 to the n plus 1 and to the n. Okay, that means we will actually have, we can add the exponents. We have to really check if these two values will give me alternating series or not. Because if this is still alternating, then it's convergent. If it's not alternating, it's just positive or negative, then 1 over n harmonic series is divergent. That's what I can do. I have to work on this one. Maybe I can work here. -1 to the n plus 1 and to the power of another n. -1 to the power of 2n plus 1. Oh. That's what do you think? 2n plus 1. 2n plus 1 is always what number? Even or odd? Like, doesn't matter what n will be. 2n plus 1, yes, thank you, Ramiro, is always odd. That means -1 to the power of odd number, it's always -1. Okay? That means I can say, I can actually remove this. I can say that my infinite series is actually 1 over n with negative being always negative. I don't even have to write this -1 to the n. That means it's harmonic, but negative. Doesn't matter if it's negative or positive, it's still divergent. Okay, that means we're not using -4 because it's giving me divergence. That means the final answer is this one, not including -4 because it's giving me divergence, but including 0. Right, so just make sure that you will test the endpoints this way. Okay, radius of convergence, interval of convergence. Let's see my next one. Oh, power series representation. Yeah, the nice and simple question and the nice and simple formula. F of x is defined as a x over x plus 3 as a power series. Of course, what I will do, I will try to get that form, 1 over 1 minus x, and this is just that value x to the power of n from 0 to infinity. And of course, x must be between -1 and 1. Yeah? Okay, that means now let's start to moving, because my function looks almost like this. I have x, and let me maybe do this way. What I will do, first of all, I will put x on the side, which I will have 1, and I will factor out 3. I will also have 1 plus x over 3. Okay. Okay, I can keep the parenthesis. We can see almost x over 3, I will keep here, and then I have 1, and minus, because we can see we have minus in the formula. Addition is a subtraction of negative number. Okay, that means this is ready for my infinite series, power series representation. It's just this quantity, negative x over 3 to the power of n. And I can still keep this. Okay, that's my power series representation. We have to clean it a little bit. We have to make it nicer, but that's the way. We're just looking at this number and we can place here. Okay, but let's see, because probably we still don't see what answer, which one is correct. Okay, what we have negative x over 3 to the power of n. We have -1 to the power of n, we have x to the power of n, and we have 3 to the power of n. Right? Now, in front of the sigma, I shouldn't leave any formulas. This is x to the power of 1, this is 3 to the power of 1. That means I will move this back here, which means I will have x to the power of n times x to the power of 1. I can add them together. Okay. I will have -1 to the n, and then x to the power of n plus 1, and 3 to the power of n plus 1. And this is done. We can still try to look really quickly for the radius, but radius is given. That part, okay, this part, or maybe this one, which is -x over 3, must be less than 1. We can ignore negative, we can multiply by 3, and we can see the radius is 3, because x must be between -3 and +3. Oh, what I'm trying to, oh, okay, just divide. Okay, that means which answer is correct? Really, don't make the mistake. I think it's A. Okay, that's the correct answer. And that will make sure that you know just the basic geometric expression. Okay, let's keep working because we still have a few things. Okay, another thing, we may try to rewrite a function as a power series and then integrate. So let's try. We have x, and we know cosine. I can write this cosine of x as a power series, Maclaurin one, is -1 to the n, x to the power of even number over even number factorial. But now I do have x cubed. Okay, that means instead of x, we will put x cubed. -1 to the n. This will stay 2n factorial, this will stay 2n, but this will be x cubed. That means whatever we will put, x cubed, x to the power of, I don't know, 5, 6, 7, just placed here. Okay, that means what we have? We have power series from 0 to infinity, -1 to the n, 2n factorial, and then x cubed to the power of 2n is x to the power of 6n. And of course, we still have to integrate. But we can see we have product, and as I said, that x in front of the sigma, we will put behind sigma. That means we will put, okay, -1 to the n, 2n factorial, because that's not, and then x to the power of 6n and plus 1. That That's the one. Okay, I think we are ready to integrate. And we remember, for the integration, we only focus on the x part. Okay, only on this one. Everything else is just constant. So in my integration, I will put actually the constant, an integral of x to the power of 6n plus 1. It will be still power series, -1 to the n, and 2n factorial at a constant. That's when I have to just copy constant. I copy everything which is not x. And now an integral of x to the power of 6n plus 1, it will be x to the power of 6n plus 2 over 6n plus 2. We remember the integration. And that's it. And it looks like that option, again, A. Okay? So we can see, just simply integrate. Even if it looks like so many formulas, we have to remember we're just focusing on the power function, x to the power of n. One more time, x to the power of n is just n plus 1 over n plus 1. Yeah, that's what I did. I did add 1. As simple as it is. Okay? And of course, know your formulas. And we may change for sine of x or inverse tangent. Yeah, you will just have a slightly different formulas, but the same concept, the same idea. Okay, now Taylor polynomials. Okay, that's what we have to do. We have to find out the Taylor polynomial. For the function cosine of 2x, just the 4th degree, okay, and centered about pi over 2, which means I can't use my known formula because the known formula is just centered at 0. It's the Maclaurin one. So what I have to do, I have to write down value of the function at pi over 2, value of the first derivative at pi over 2, 1 factorial, x minus pi over 2 to the power of 1. And then I have to say the second derivative at pi over 2, 2 factorial, x minus the center to the power of 2, and the third derivative at pi over 2, 3 factorial, x minus the center to the power of 3, and the fourth one. That's the third one. Okay, the fourth one at pi over 2, 4 factorial, x minus pi over 2 to the power of 4. So we simply have to find out like all of the values. And I will build the table, you remember. Let's find, this will be the degree, 0, 1, 2, and 3, or actually 4. And can you see, probably it's what I did on the top. If you will have this type of question, I will really recommend to write this down. Or even practicing like now. Even if you think, oh, I know, oh, she's like repeating second derivative, 2 factorial, third derivative, 3 factorial. But it's really, if you will write this down 2, 3 times, you will know this right away. You will never make the mistake. Okay, that's me, please, yeah. Take my recommendation. Function is cosine of, oh, hang on, because we need the values also. We have function cosine of 2x, but we will also need the value at pi over 2. Let's see what we have. Okay, cosine at, this is just function. 0 means just the function. 1 means the first derivative. Okay, you have to help me because I need first derivative, second derivative, third, and the fourth. First derivative is definitely negative sine of 2x and times 2. Correct? Please check because we always have to think, and I don't want to make mistake. Okay, the second derivative, derivative of sine is sine of 2x is cosine of 2x times 2 which will be 4, and negative will stay. Derivative of cosine of 2x is negative sine of 2x times 2, which negative and negative will give me positive. And then derivative of sine of 2x is cosine of 2x times 2, and actually positive. Yeah, derivative of sine is positive. And now instead of x, I have to substitute pi over 2. Cosine at 2 times pi over 2 will give me pi. What's the value cosine at pi? Are you still there? I know that the session is a little bit longer. Cosine at pi? Oh, cosine at pi is negative 1. Thank you. And we can see negative 1, negative 1, negative 1. Oh, negative 1. That's not our option. Yeah, we can take. Okay, sine at pi actually is 0. I like this. Sine at pi will be 0. Okay, cosine at pi is negative 1. Negative 1 times negative 4 will be positive 4. Negative 1 times 16 will be negative 16. Okay, that means that's my final answer. I will try to repeat. The value of the function at pi over 2 is negative 1. And then value of the first derivative is gone, 0. That's we don't have it, okay? And then the second derivative is 4 over 2 factorial x minus the center to the power of 2. The third derivative is 0, really good. And the last one, the fourth one, is negative 16 over 4 factorial x minus to the power of 4. Okay, that means which answer is correct? 4 over 2 is actually 2. That means I think this one works, and negative 16 over 24, because this will be 24, dividing by 8 is negative 2/3. Okay? That means this is the good answer. The reason that I put this back, because I can tell you the common mistake is to pick this answer. Because you see 4 and you see negative 16, and right away you circling this answer. Okay, but of course not, because we still have in the formula, we still have factorials. Okay, that means remember to include them in the answer because they affect the coefficients. Okay, definitely Taylor's polynomial. And now, using Taylor's polynomials and some approximation, we have some errors, and we have to know how to estimate these errors through Taylor's inequality. Okay, that's what we have. We're doing this estimation. We're estimating a function by the 3rd degree polynomial, and the function is natural log 1 plus 2x, centered at 1. Okay, centered at 1, and we can see we're only going away like half of the units. And that means the radius is half. Because if I will draw it's centered at 1, and it's going from 1/2 to 3/2. Yeah, that means the radius is, the maximum is half. Okay, but using the 3rd degree polynomial approximation and the Taylor's inequality, okay, let's write the formula. 3rd degree, the error of the 3rd degree polynomial approximation will be less, and we remember also from the alternating series estimation theorem, will be less than the next term, which means 4 factorial. M is the maximum value of the 4th derivative, which we even provide this, and then x minus, let's say a for now, which actually we know what is a. I was looking for the center, 1. Okay, to the power of n plus 1, which actually it was 3, the degree was 3, we have to have the next one, 4th, the next term. Okay? Like, let's look at this. Yeah, we can see this is like the 4th degree. That's when we end up with 4th derivative, 4 factorial, and to the power of 4. which means if I will do the approximation, I will say fifth, for the Taylor's inequality, I will say fifth derivative, 5 factorial, and x minus the center to the power of 5. Since we're doing the third degree polynomial, I have the fourth derivative, which we will call m for now, 4 factorial, and to the x minus the center to the power of 4. Okay, and we have to compute this number. This is 24, but let's maybe compute m. M, as I said, is the maximum value of the fourth derivative on the given interval. Okay, -1 to the power of 3. I'm just copying the fourth derivative, which actually I can write this. Fourth derivative, okay, and always maximum value, which means just here, just the absolute value. Okay, we have to find the maximum value of the fourth derivative on the interval from half to 3/2. Okay, -1 to the 3, which will becomes positive anyway. 2 to the power of 4, 3 factorial, and 1 plus 2x to the power of 4. That means this is my derivative, the fourth derivative, okay? And now, in order to maximize this number, what value of x shall I pick from my interval? Okay, we can see my x in the formula is placed in the denominator. In order to maximize a fraction, I have to minimize a denominator. I mean, this will become 1. This is 16. 3 factorial is 1 times 2 times 3 is 6. And then 1 plus, and instead of x, I will actually put the minimum number, 1/2. Okay, that's 4. And you can help me with the arithmetic. 16 times 6. 1/2 times 2 is 1. 1 plus 1 is 2. 2 to the power of 4 is also 16. The answer is 6. Really nice. And x minus 1, it's also like, I mean, let's do this way. Instead of x, you can actually put any of the endpoints. Because since it's absolute value, you will always maximize. But overall, this answer, whatever you, oh my gosh, I'm really sorry. I thought that I have. Whatever you will put instead of x, you will always get the radius value. That means we're supposed to get 1/2. And we can try. Okay? But if you really like more structure, you can put 1/2 minus 1, which is -1. Absolute value of -1 is +1. Or you can put the other end, 3/2. 3/2 minus 1 is 1/2. Absolute value of 1/2 is 1/2. That means I'm just trying to tell you, whatever you will substitute for that x, you will always get a radius. Okay? Which actually I don't even have to put the absolute value. Okay? Always, because it's maximum, we have to go up to, like, we have to compute this error like to the maximum accuracy. Okay, that means this is my final answer, and let's do the arithmetic. 6/24, of course, is 1/4, and this will be 2 to the power of 4. 2 to the power of 4 is 16, and who can tell me 4 times 16? 4 times 16, it is, of course, 64. That means my error is less than 1/64. Okay, that means that, and that's also the nice question, an important concept. But remember how to set up an inequality. Okay, if it's 3, 4, 4, and the fourth. If this will be 5, 6 factorial to the power of 6, and the 6 derivative. I can say this is my m. Okay, m because we're looking for the maximum value. Okay, what else? That means this is, I believe it's everything from chapter 11. That means what we can do, I can keep working on chapter 10, Or maybe we can, no, let's do it, because maybe we can, like, let's 10-15 minutes. I know that it's a little bit longer, but yeah, if you really have to leave the session, you may leave the session. If not, you can still stay and I will just finish a few questions from chapter 10. Okay, that means chapter 10, we have two parts. We have the parametric equations and parametric coordinates, and we do have polar coordinates. That's one of the questions that we may ask you for the slope of the tangent line for the curve that is defined in the parametric way. Okay? And we can see x has its own formula and y has its own formula, and the point is given. That means asking for the slope of the tangent, of course, we're asking for the derivative. That means slope of the tangent, it's simply, let's say, derivative. But since we have parametric equations, we know that we have to, it's kind of like dy dx, we remember that, or I can say derivative of y, derivative of x, because both of them depends on t. And that means just, you may remember this, derivative of y, derivative of x, and since they have own formulas, it's derivative of y in terms of t, derivative of x in terms of t, and we have a t value. It's mean nothing simple. Okay, let's start with derivative of y. Tangent t. What's the derivative of tangent? Derivative of tangent is, who can tell me? Are you typing? You typing, okay, secant square of t, really good. We're done with the y. Now we have derivative of x, which is defined as a secant square of t minus 1. Derivative of 1 is 0. That means secant square of t. Derivative of secant square of t will be 2 times secant, and derivative of secant, because follow the chain rule, it's secant times tangent. Okay. And we can nicely see, I can simplify secant square and both of the secants, and the only value that stays is 2 times tangent. And now we have to compute the derivative. Let's maybe use like a f function. Okay, just like, because I don't like using y for the second time. And we have to substitute, oh, not pi over 2, I was just writing negative pi over 4. Okay, 2 times tangent, I'm trying to negative pi over 4. What's the value? What is tangent for negative pi over 4? It's not 1, it's negative 1, because it's odd function. Negative half is the final answer. And I believe we have this option. That means that's the slope of the tangent line at the point negative pi over 4 for that curve. I mean, what is the concept is here. Please remember that. Okay. Now we may ask you to convert from Cartesian to from the parametric equation to Cartesian, which means we have to eliminate t. That means this is a little bit different than the polar. Yes, we don't need these equations. We have to just look at the formulas and like play around. Normally what we will do, we will solve one equation for t and substitute to the second one. Okay, but this one looks a little bit different because y, we can take the advantage of the formulas, is defined as a e to the t squared. And I can solve the first equation for e to the t. It will be x minus 1. I mean, my equation is e to the t squared, but e to the t is just x minus 1. That's it. X minus 1 squared. That means this is the equation. We may still like have some, don't worry for this. You may probably ask why x is greater than 2, but we can look at this equation. X is defined as a e to the t plus 1, and t is greater than 1. We know how e to the t looks like, okay? let's say this is t, and this is my function. Okay, that means starting from 1, if t is greater than 0, the maximum value is 1. That means this is 1 plus 1. X will be never less, will be always greater than 1. 1 plus 1 greater than 2, because this value is 1, if t is greater than 0. Okay, e to the t. But don't worry, we're not asking for this, we're just stating this because we want everything to be mathematically correct. We're asking for the equation. Okay, let's see. Now we have the other way. Oh no, this is the polar. Okay, that means now we have the moment that we have to write down all of these equations. Find, a polar equation for the curve, Cartesian curve, is one of them. And we have to find which one. That's what I will do. I will write this right away. X squared plus y squared is r squared. X is r cosine, y is r sine, and tangent theta, it's y over x. Okay. Okay, that's what I have. I have x squared minus y squared. I can possibly say that x is r cosine theta and y is r sine theta squared. X squared plus y squared is just r squared. Okay, let's distribute r squared cosine squared theta, r squared sine squared theta. Okay, and this is just r, assuming that r is positive, of course. We can factor out cosine squared theta, sine squared theta, r, and I can divide by r, then I will have only r and 1. And who knows, who can tell me what is this formula? Cosine squared theta minus sine squared theta. It's cosine of the double angle. Okay, that means that's another formula that we have to know. But probably for the integration, you remember that formula for section 7.2. Okay, that means that's done. This is my final answer. Okay, let's do the other way. We have polar equation and we have to find out the Cartesian. Shall I do this? What's to be just x squared plus y squared, x, y, and tangent theta. Yeah, this is r cosine and this is r sine theta. Okay. So now what I have r sine of 2 theta. I will write my formula. 2 times, that means you can see the double angle. Sine of 2 theta is 2 times sine times cosine. Okay. And what I can do, let me keep r squared for now. And then, actually I can divide by 2, then this will become 2. Okay, I can actually keep it. Okay, sine theta is equal to y over r. And cosine theta, it's of course x over r. It means this one is y over r, this one is x over r. That's the reason that I didn't put for r squared, I didn't put x squared plus cosine squared, because now I have x times y and I have r squared, and I can cancel out. Okay, x times y is 2, y is simply 2 over x. Really nice. Yeah, simplification. 2 over x is just the hyperbola. But again, I will recommend to put them down. Okay, and what else we have? We do have the last part, section 10.4, the areas. That's, we remember the session, we remember the shapes of the curves that we have to recognize, and then drawing them really quickly, we will see the correct settings, correct integral. Let me start maybe, oh, I saw this one. Yeah, let's maybe, because that's the nice and easy question, let's recognize the curve. Curve is 1 plus 2 cosine theta. What do you think? Which one is definitely not the right one? Do you remember my session? Like, which one is definitely, we have 1 plus 2. Yes, CDE, exactly, okay. CDE, that's not the right one, because that's cardioid. Cardioids, they have to have the same coefficient, 1 and 1, for example, 2 and 2, and that's circle. Okay, that means it's the limaçon, the cardioid with the loop. And what do you think? Since you see cosine, which one is the right one? Of course, it's B, because we need more values. Yeah, exactly, exactly. Okay, that means, yes, you know the shapes. I solve one of them. Okay, that means let's just solve maybe 1 or 2 problems. Which integral represents the area that lies outside a cardioid, okay, and inside a circle? Okay, that's we even have the names. I will draw this, okay, first. Let's see if I can do it. Okay, cardioid, it's 1 plus sine theta. That means we definitely know that the cardioid is, more symmetric. It's something like that, or maybe something like that. Because it's sine, that means we can't have the cardioid this way, because we can't have longer on the x-axis, we remember. It will be longer on the y, on the 90 and 3 and 270. Okay, that means, let's say, this is 0, that's 90, 180, 270, and 2 pi. Sine at 0 is 0, 0 plus 1 is 1. Sine at 90 is 1, 1 plus 1 is 2. Okay, we know the shape. This will be this way right away. Okay, and now 3 times sine theta. A circle in the first and the second quadrant, okay, but this will be 3. Okay, shall I draw it? Oh, I lost my pen. Okay, not bad. And now what I need? Outside the cardioid and inside the circle, which is that part. Everything is nice and symmetric, we know that. And we just need this, not this line, we need these points. Okay, we need points of the intersection. Of course, we will use the symmetry, because we will use just half of this and we will multiply by 2. But we still need this. And let's find this. One curve, 1 plus sine theta, must be the same like 3 sine theta. Subtracting sine from both sides, we have 2 sines, and then I can divide by 2, we have half. Sine for what angle is 1/2? For pi over 6 and for 5 pi over 6. That's pi over 6, and this is 5 pi over 6. Okay. Integral, and now we know that we have to subtract, I can write the general. 1/2 r squared minus 1/2 r squared d theta from A to B. But this must be the top one, I mean the longer one, the longer radius and the shorter. And the longer is a circle. We can see this one, that means this one will be the first one, this is the second. Let's put 1/2 in front. R squared minus r squared d theta. R squared, which one is the longer? The circle, 3 sine theta, and the cardioid is the shorter radius. Perfect. Now my limits of integration should be from pi over 6 to 5 pi over 6. But as I said, I would like to use my symmetry. I will stop halfway, pi over 2, okay, and I will multiply everything by 2. Oh no, this means that no, why is changing? 1/2 n times 2 will be gone, but this is still the good limit. That means pay attention to, okay, to upper limit, pi over 2. And which one is good? No 1/2, of course. You have to help me. B, I will circle B. Yes, because this one is missing the square. This one is missing the square. This one is the other way. It's 9 sine square minus the cardioid squared. Okay. Okay, that's what I can do, because I still have, I think, one question, and I solved this one for you. Okay, that's when we can probably, where is my camera? We can probably stop, because it's just practicing. I will write the other question for you, because it's just yet the same thing. And also each sample test, practice test, includes like questions like that. That means what you can do, what you can expect half of the test to be covered by this section. Okay, half of your final test. That means now, because we're still working on the final, I know it's open Friday. Okay, you probably didn't see the 200 points in the grade book, but we still like adding and removing questions. But please do not miss any question from this session, okay, because that could be half of your test. Okay, thank you very much for staying with me like half an hour longer. Thank you for your participation, and good luck with your final exam review. You may still post some question on the discussion board, and I'm trying to monitor. I did solve 2 questions at the beginning of this session, but you can still post question, and I will answer. Or you can email me if you feel more comfortable. Okay, thank you very much, and good luck with your test.